on Open Science Research Labs on Discord and getting more people. This was published on September 6, 2025 by Sion Gunness. The TLDR is there's a bunch of groups on Discord that are doing glorified open science, AI research, and I think you should join them. Chapter 1, Definitions. This is not about open access or open source. Those are the concepts of having papers and code available, which are good things. This is also not about citizen science, where you have citizens do work for you. An example of this would be the NASA space program, where one time they had a bunch of images of space that they classified, and they got a bunch of citizens to come and classify the rest for them. This is related to open science though. It's just open science tends to be a bit more advanced. Apps and startups that mimic current solutions without offering research contributions also fall outside of open science because they emphasize product development over knowledge creation and often require a different mix of skills, priorities, and evaluation criteria than academic or interdisciplinary research collaborations or like the independent science labs. An example of what this wouldn't be would be like Vine, cause Vine didn't really do anything other than have a shorts format, which isn't really research worthy. This is about open science labs. That's the concept where online researchers of varying skill level, but usually around master's equivalent or higher, come together to do research. This usually results in some kind of research paper, or blog post or conference or something like that, and usually has lots of interdisciplinary involved. I should probably change the name though, and I know that masters is a bit of a vague term, but I think like if they can re-implement cutting edge papers, that's around what I mean. Chapter 2, The Rise of Open Science Labs. Discord as a catalyst. So after around 2017, if you've never used Discord, it's kind of like IRC, where it's kind of like an instant messaging platform, and there's a lot of groups, like there's scientists and mathematicians on various servers on Discord, and there's a lot of people of various subfields as well. I think before 2017 there used to be this, but it was more so like to help with GitHub projects and stuff, so I guess it's now also improved to the point where people are now collaborating with like papers and stuff. I think the reason this occurred in Discord over something like Slack is ease of use. This has led to some of these spots turning into glorified open science labs, kind of like a research lab. People come together to do work on a research problem. Some examples would be the Busy Beaver Challenge, where the Discord group found a solution for Busy Beaver 4, I think. Various AI and informatic Discords writing research papers. Discord groups doing GitHub repos for some of the academic tools, and it's also led to a lot of interdisciplinary work between subfields and greater fields. So like some AI Discords now have people in psychology, data science, and maths helping to do stuff, or the various bioinformatic working groups having people from various subfields, as well as just like people learning more about other fields in their related subfields, for example, so like mech-interp tokenization and stuff. This is different from groups doing collaborations for a hackathon or a general chat server about a specific field. For some types of Discord communities that are related, there's the GitHub-S working groups, which tend to work on one specific GitHub repo or sometime a few, essentially working like a chat for the GitHub repo. Then there's the hackathons and entrepreneurial groups. They tend to be more for like networking, meeting co-founders, running startups, or really like for any developers who want to go into the startup sphere. They tend to run like demos, collaborations. If there are hackathon groups, they tend to put collaborations for the hackathons. And they just do like MVPs, networking, lots of business and startup stuff essentially. Then there's the study groups. They tend to be more for undergrads, which is very unfortunate. They're really good for anyone who wants to upskill. They tend to have like reading groups, accountability groups, co-studying. But I think because they're so broad, they just aren't much study groups for like a specific subfield, more so like for the greater field. So like you can probably find something for like linear algebra or something like for how to do deep learning, but you won't really find something for like flow matching. But within these study groups, you can sometimes find an accountability partner to help you study. I know I put Yannick, Kilcher, and Fast the idea, but they're closer to education servers, which are kind of similar. But Yannick has a YouTube channel, and FastAI has a course, and Flash Linear Attention is also kind of a course. Then there's the graduate and industry chat servers. They are more casual. They sometimes help with your own research topic, but I've always found them closer to like Stack Exchange 2.0. They have various discussions on field and stuff, but they're not really like research based. It's more casual. Like you can get people to help you there, but I don't think it's really the point of the server. More so just to chit chat about like work, research, studies, and stuff. Kind of like a grad school hangout and Stack Exchange in one. Finally, there's the Open Science Labs. They collaborate on public and open research. Sometimes you can bring your own, other times it's other people from the group. They tend to have like scientists, independent researchers, PhDs, postdocs, really anyone in the field, and sometimes anyone who think they can help and tend to learn quickly. They tend to run a lot of various activities such as reading groups, working groups, running tests, code and data reviews, paper support. They tend to output research papers, reproducible code, tools, and blog posts and write-ups. They are decently active, especially if funded by a larger organization. They tend to have an easy-ish onboarding if you're more skilled, such that you can just have an introduction and then look at some of the projects to do, or just go to the reading group and find one you like. There are also high school open science labs, but these feel closer to spaces where you make or do something new rather than like strong research. There are separate tracks for them in various conferences, but they aren't the same as regular research papers. Closer to a small project a company would do for a community. They're still very impressive, but doesn't move the field forward. Mostly because of the lack of required knowledge, because, they're high schoolers. If you're listening to this, right now I put an image here. You are almost certainly aware of this image. It's that image with the circle that contains all of human knowledge, and when you're done with a PhD and wrote a paper, that circle gets a tiny bump because you've made a dent in all of human knowledge and expanded it. Chapter 3: How Open Science Lab Works. The day in the life of a researcher in an open science lab is decently but not quite the same, similar to someone doing research in a university. Writing a paper. If you have an idea you want to work on, you can usually post a thread looking for collaborations if you need specific help. Otherwise, you can look around and see any that are interesting. It's generally a good idea to show some level of progress or work done though, such as code, papers you've read, a strong write-up. An idea just doesn't get much traction, especially if it comes from a newcomer. It's kind of the same thing in entrepreneurial spaces where you have a startup idea person who wants you to develop their idea because it's an amazing app idea. The same thing goes for paper idea. Please don't do that. No one's going to look at it. Please have something or some level of work done before you post an idea. Sometimes the Open Science Labs has their own projects as well, which tends to get a lot more activity. This can mean either papers they are writing or GitHub projects they are doing, which relates to the paper. Example, a paper can sometimes be a dataset, a new large language model, a technique, or something else where code is released on GitHub plus the paper write-up. Usually you'll need at least one decently skilled person in these open science group to lead the paper. Otherwise, it will lead to people not being sure what to do or make biased results. It can also lead to a situation where one person does most of the work as well, which for both hackathons and research papers are usually fine. if the others are here to learn and they understand this beforehand. In other words, don't expect a spot in the author list or cash prize if you've done pretty much nothing. It's kind of like a research org with one senior helping a bunch of junior scientists. This is very paper dependent. For example, if it has a lot of grunt work like data cleaning, you might see people who probably shouldn't be doing research yet join to do some grunt work and learn along the way. The papers are your own if you did the majority of the work. Sometimes you might give them, that is the Open Science Labs, special thanks so they can get funding. If you don't do the majority, you usually still get the part of the authorship. And this can vary since most community projects are created by the community rather than top-down or by organizers and admins and stuff. Like, I've seen a bunch of independent researchers put the name of the online lab as their organization in active papers. Related to this, there are also fellowships which tend to be either in real life or otherwise more intensive. There's also like hackerspaces and stuff. People from these online labs sometimes host a track there. Most of the time it is a paper being done. Fellowship tends to refer to multiple things, but it usually means some sort of advanced training with a paper in the end. Learning resources. There are also research paper reading groups in these open science labs. These spots usually have a lot of resources to help people work on a project, given that they're already decently skilled. So like if they can re-implement papers or close to that level. Like if they're new to Python, they probably shouldn't be here yet. If they don't know the general path to upskill, like because they've been searching and Google search has been hijacked with paid courses that just don't help much, some of the labs are willing to redirect you to the learning Discord and study groups or their own pathway to how they reach where they are. Or sometimes they'll just tell you to join the reading groups and replicate some active papers depending on your skill level. Like, there's a lot of people in the open science labs that has around a master's or below level formally, especially in the AI spaces, just because they're self-taught afterwards. The reason research paper reading groups exist in open science labs is because it's kind of like literature review. Learning spots usually don't have that, and advanced courses tend to have whatever subfield or niche example or capstone project you're working on rather than regular reading of papers. That is, they'll probably have like one or two capstone papers that you'll have to replicate or something, which can sometimes be outdated or used in industry only. Specifically, what skill level should I be to write or help? Essentially, you should be already past AI 201. Otherwise, best to reach to that point. Once again, there are study groups and resources to learn to reach to this point. Or in other words, around the skill level of being able to use Hugging Face, build pipelines, and so forth. Although probably best to be around the skill level of replicating a paper if you're planning to write one rather than assist with one. Other subfields probably have around the same classification. Junior if you're helping, senior if you're leading. Mostly for the extra theoretical knowledge that comes with being a senior. That's not to say you need strong theoretical skills to do research. You don't need a strong formal math background to optimize AI. You can just try things and see if something works and figure out why it works afterwards. Example for interpretability, you can use the systems to interpret how a model works without requiring a topological understanding of the mathematics. Usually your peers, AI, and so forth can help. This is probably because AI still has a lot of low-hanging fruit, and a better understanding of the problem is a better way to do things than learning theoretical math to try to attempt new stuff. In other words, you should just try to do things. Like a lot of the Kaggle competitions I know, rather than like trying to build some strong theoretical knowledge of how it would work, they tend to just build a model, then iteratively optimize. If you're here for the reading groups, you don't need any background to join. The requirements to write a paper are more of a soft requirement because of the problems with crackpots, which I'll be getting into later. Most reading groups are also uploaded to YouTube, and then there's also all the unis and stuff also posting on YouTube. And then there's a site called researchseminars.org. Academically, if you already did a diploma or degree, you're usually 1 or 2 years away from writing papers. In other words, PhD students write papers, not so much PhD holders themselves. Please do note that interpreting how something works after you've measured it does not work for other fields, especially humanities. So what's the skill level looking like? I ran a quick poll on the Mechanistic Interpretability Research Server, and the results are as follows. 40% said they have written a MechInterp paper or some sort of blog post before. 6% said they've done major MechInterp work before. 11% said they've done ARENA, that is, a major MechInterp course. 9% said they've done a MechInterp course similar to ARENA. And 34% said they have not done any MechInterp but wishes to. There is some bias because none of the lurkers did the survey, as well as that 34% could mean anything from PhDs in different fields to complete beginners in Python. I messaged Neil Nanda about his MechInterp team, and he said, of the soon to be 8 people on the Google DeepMind MechInterp team, 2 were maths bachelors, 2 were maths masters, 1 ML PhD, 1 ML PhD dropout, 1 stats PhD dropout, and 1 physics PhD dropout. A few of Neil's math scholars also had ML PhDs, but those were non-trivial. Thanks again, Neil, for sending me that. Chatting with people from the maths track I went to back in 2023, a decent amount of them had completed undergrads at most. This might be track dependent, although I don't think that will change much. Neil had no industry experience before getting into AI. He did some non-AI internships pre-AI. I think this shows that a lot of the AI researchers don't have more than like an undergraduate or a master's background. Open Science Lab tends to be funded by 2 main groups. The first one is the philanthropic or charity funded labs. These tend to be focused more on theoretical type research such as toy examples, new techniques on smaller models, interpretability, and so forth. They sometimes get funded by grants. The effective altruism groups sometimes fund these labs. The money is used to pay for the core team and anything else that's needed. Theoretical in this sense just means they aren't building AGI. Like they're still releasing code and stuff, and some of the code can be used together in the future to create better benchmarks and so forth. Then there's the DAOs. These are a crypto collective that gets a lot of funding from crypto that then funds various research that other DAOs do. The DAOs tend to have various informatics, supply, production ready to fit into a pipeline type research. They tend to be more focused on like bioinformatics, cheminformatics, drug discovery, and so forth, rather than like AI research. Things do feel different in the 2 spots. DAOs feel closer to like industry, labs closer to academia. DAOs tend to have a less top-down structure and more decentralized, while the charity-funded labs don't. DAOs refer to decentralized autonomous organization. They tend to be blockchain driven essentially, and the members vote on decisions, usually. Something of note is there's also the open source research hybrid. Some open source groups usually have some sort of paid service or product that consumers can buy. For example, an API for an AI model, sometimes paid one-on-one services, sometimes conferences, courses, and so forth. They are usually part of a company, so they get investor money and so forth. People contribute to like bug bounties, and they usually get a job sometimes if they do enough bug bounties. As a whole though, there isn't much funding for these kinds of stuff, especially compared to academia, and significantly less funding for anything not in AI. Maker spaces and so forth are IRL based, so they tend to get more funding for their IRL stuff. And DAOs tend to be closer to like a funding organization. People can pitch their project ideas, and if other people like it, they can buy their coins, and they can then use their coins to fund their research basically, or direct where the funding goes if the DAO is more of a funding organization type DAO. Research managers. In a lot of the groups, more notably in spots where the admins, who are usually subject matter experts, they take on the role of a research manager, akin to a mentor. They give guidance for other problems, they question assumptions, they introduce you to other researchers, or otherwise really help you along with your own research. Besides that, they sometimes help with funding, conference stuff. They have a really high level view of the landscape, they have good research taste of what the field is up to, or otherwise just outright help you with complicated issues if required. They aren't too common, and sometimes the lead takes on the role of a research manager. There's also always the community managers, who always helps with community events, discussion, building, and so forth. Chapter 4. Problems in Open Science Labs. The Crackpot Problem. Crackpots come into Open Science Discord labs and spew their nonsense ideas, looking for validation, usually being guided to the server via ChatGPT. They get banned. The hackathon spaces and entrepreneurial spots tend to also have this problem, but it usually results in people not taking them seriously or people attempting to write code that doesn't work. There's a non-zero chance this fixes itself in the next iteration of AI, if the next iteration decides to call all their ideas stupid and help them out instead of bringing them here. If more people pop up, entire servers can be full of crackpot and crackpot ideas akin to Vixra if quality control is not done. Problem 2. A lot of projects go nowhere. This isn't really a problem, but a lot of users start projects that get abandoned very early on. This is because of activity issues from the members involved, the project was not good, or most likely the poster just wanted to post an idea rather than actually do research. Or that thing where it's easy to start a project versus continue because it mostly seems easy early on. Failures in research. Those especially new to research, coming from an outside perspective, finds it hard to realize you can do research for 100 plus hours and it ends up sucking, especially if they haven't done something of that scale before. An example would be an app or a game or something, which usually causes an attack of the research to mean an attack of the person from their point of view. Communication issues. There is also a communication issue at play, where a user might misinterpret what an expert tells them. This is usually common if the user has been using ChatGPT to help them with their message. Onboarding difficulties. Skill levels can be quite varied. It's hard for someone who's new here to rank their own skill level, Dunning-Kruger and all of that. This can lead to a situation where a new user joins, looks at some projects, thinks they're all difficult and leave. Except if they decided to spend a week with the project, they would have been able to help. This is the theory-practice gap. A user join, looks at the projects as well, and never asks to help because of imposter syndrome. People more new to Discord get overwhelmed with all the options and leave. A lot of people join and say or do nothing. This is probably related to larger issues regarding work ethic and just joining something and then just not using it, like all of the people who joined the gym in January then just leave it. For community made projects, sometimes people just don't know how to help with a project because it was badly worded, or because, like, let's say the words the poster used were words that are more common in like a math background, but all of the people who want to help are like in computer science background, and because of this the poster leaves. Also, there's various Discord problems. The biggest one is because of the fact that it's more of an instant messaging platform rather than like a forum. It leads to topics being switched quickly. Most groups fix this by having specific channels for each topic and some kind of log for what everyone's up to. Chapter 5. Successes in Open Science. Impact. These places usually have best paper and other conference papers, active papers being done every year. Successes in Open Science. Impact. These places usually have best papers and other conference papers as well as like active papers being done every year. Luther AI got a 50% acceptance rate to ICLR this year, as well as a lot of papers on Active and some high impact. Cohere also has a lot of papers on Active. I think they have some NeurIPS papers. DAOs has millions of funding that are being used to fund various projects, such as VitaDAO, which does longevity work, ValiDAO, which does synthetic biology work, and various other DAOs. The Manifold Research Group got 6 papers out last year. ML Commons got 2 papers out. Medark is doing quite a lot of work, 7 papers out since 2023. And Active Inference Institute does a lot of various stuff related to the larger ecosystem. There are also some groups working on large language models and other useful things that I thought I should note. Open World Labs, they are doing open research on building a world model and dataset from video games. Noose Research, they build various AI models, notably the Hermes series. Apart Research / Alignment Jams, they host various hackathons for AI policy and research, with the winners moving on to a sprint that results in blog posts. Note that the winners sometimes do their own thing as well. I know at least one person was able to move their idea to a product after the blog post. AI Safety Initiative at Georgia Tech. They are a general AI policy research group with lots of resources to find funding and so forth. Duck AI, they do various AI stuff, all their outputs are on GitHub. The Open Model Initiative, they are building an open AI model. MetaUni, they are a large group hosting various talks and reading groups and so forth on Roblox. AI Plans, they are an alignment research server. They do alignment research, sometimes they run law hackathons and various other types of sprints and so forth. AI Safety Research is shared and discussed here. The RWKV language model, they maintain the RWKV architecture. The RADVAC working group, they make vaccines accessible for all by doing vaccine research. The BioXYZ is the hub for most of the DAOs. BioXYZ funds most of the DAOs. The Busy Beaver Challenge, they were able to prove Busy Beaver 4, I think. DeepChem, they do deep learning for drug discovery, quantum chemistry, material science, and biology. It's all open and anyone can join. Independent Scientists, they're a new group. They seem to be working on various physics problems but might branch out into whatever the community wants to do. There's a bunch of other groups, but they tend to fall into one of the other labels in the types of communities table. Most of these are GitHub working groups where they work on a singular GitHub issue or project. There are some that also does research paper reading groups without being a research lab as well. The one that comes to mind the most for me has to be Yannick Kilcher. MetaUni would be one as well, as they mostly run reading groups rather than like research. People share their research there essentially. There are a lot of different types of open science labs, but they can mostly be broken down into 3 types. Everyone's insanely skilled, so not much reading or upskilling required. Usually, there's a bunch of masters and PhDs in different subfields, so they just help each other out. And they start doing work on any of the issues or write papers and stuff. 2. Less skilled, so more events, more low-hanging fruits that are being done instead of more difficult problems. You'll see more upskilling here. You usually see links to education stuff here as well. You're slightly more general audience, so you'll also see larger team sizes as well here. It's a lot more relaxed here, I guess. 3. Turn things into a token or some kind of hackathon by talking to the experts about what needs to be done. So the admins talk to the experts and then they run some hackathons and the community finishes the hackathon. I can't compare any of these to regular universities, mostly because I can't seem to get a solid number on how much papers a uni publishes each year. But I am almost certain the paper cost ratio is lower, but that might be just because it's all computer science and AI, which has lower cost because all you need is a computer to do work. As well as people who are here are usually self-selected or already high skilled, so not much funds needed to upskill, especially because it's all online. If you're listening to this, I made a graph here. It shows that about 0.25%, I'll say that again, 0.25% of NeurIPS papers for 2024 were from open science labs. Of course, there's a lot of non-NeurIPS papers being published, as well as there's some open industry labs. I know Allen Institute had 31 research papers, but their Discord is more for users rather than researchers. I think that's because to be a researcher in Allen Institute, you need to join them. You can't just go to their Discord and collaborate. I think you have to submit GitHub repos, or I think you have to apply for them. There are various IRL hackerspaces and fellowships and so forth that sometimes produces high quality research by undergrads and high schoolers, but that's pretty rare. Like, I know one time there was a 17-year-old who was able to disprove a conjecture from one of those, but it's exceedingly rare, I guess. Non-paper impact. Besides these places have also been a great spot for hobbyists and anyone who self-studied to apply what they learned, or otherwise help with policy experts, SciComm, or so forth. They're just a great way to network or move into startups if an idea is strong. They're also great to like finish your research project or get help or like collaborate with an active paper and so forth. Most of these spots also have labs, sometimes IRL offices or something of that sort in IRL spots, as most of them are companies or non-profits. Also sometimes companies can be formed from these groups. Like, I know both eLuther and I think Manifold has companies that were formed from them. BioXYZ has done a lot of funding for various research, and Cohere has created a model among other things. Cohere for AI also has the BIRDS programs, which helps bring people of various skill levels into research, usually by doing cohorts of reading groups and so forth before doing any research. Most places have reading groups as well, which has similar effects. This is really useful for teaching junior researchers or people new to research how to do research. These places also serve as a great spot for interdisciplinary studies, reading groups from different subfields, which can help with your progress if multiple different subfields are looking at the same question, for example. Usually after a few years of being in these spots, you just tend to leave to go into industry. They get hired, they take on problems from the value of that in innovation. That's the gap between the industry and academia, where papers go to die since it's not scalable, or just advance their own research, or like make a product and so forth. Once again, if you're listening to this, I posted another image here. It's an image of all the reading groups I have right now. It's a lot, you should see it. I don't go to most of these though. How to upskill, the alternate path to doing PhD-esque research with little formal education. You can do a top-down approach where you get some state-of-the-art papers and replicate them with Claude, or you can go through a more pseudo-standardized pipeline of the various courses for AI. For example, you can learn basic Python, and then you can learn the more advanced AI at the Fast AI course. Then you can pick a subfield, for example the Arena course for Mech-Interp, GPU mode videos for low-level stuff. Then you can replicate papers and do research. From here you can then go back and learn about adjacent stuff that might be useful to you, for example stats and maths. This shouldn't take more than a year, and you can go top down instead, as you'll pick up more as you learn along. Note that subfields in AI are pretty close to each other, so you usually only need a week or 3 to understand what your peers in another field, for example audio or image, are doing. Even those further away, for example low level, applied like bioinformatics, probably doesn't take more than a few months. An understanding of research as a whole is useful to help ease friction as well. Understanding the ArXiv system, papers, conferences, and those sorts of stuff are pretty useful. You could ask AI this, you could probably watch a few videos on how to do research. I did also link a few videos and resources myself on how to do research further down. These are especially useful if you've come from an industry background. For example, you have a lot of years in Python and data science working in the industry, or something, as it's usually that can cause friction, or just you are not measuring what you think you're measuring correctly. A strong example of what I mean by not measuring what you think you're measuring correctly would be like videos and essays and so forth from Skeptic's Guide to the Universe, or just like knowing your biases in research, or just the research checklist to make sure you aren't falling for any biases or fallacies and so forth. So for top down, on the other hand, you can grab whatever the state of the art paper is, replicate it on its GitHub, and then ask Claude Opus to help, and pairs whenever Claude is unable to help you. You can repeat this a few more times, replicate in some more papers, making sure you understand what each of the lines of code does, the choices for the code. You can ask why they did it the way they did. You can probably try to optimize it. It's kind of the same as Googling and copying the info and then reading the info and having an understanding of it. If you don't know what to do for most of ComSci and AI or asking research question stuff, you can try asking Claude Opus. It's really a great equalizer or $1 million tutor at your fingertips. It can massively accelerate learning speed. Realistically, you'll want to do a mix of both top down and bottom up. Re-implement the paper, have an AI explain every term that was used in the paper, and eventually the model links you to a course or something. You do that course and you learn. The Fast AI and the CS Transformers also has Discord communities as well as a study course online. A few other fields tend to have some sort of study course and community as well that are decently good from what I can tell. Or if you're not sure as yet what subfield you want to go into, sometimes these spots, most of the research servers and so forth tend to have like an overview of all the subfields in the field that you want to go into. So for example, an AI grad server would have most of the AI subfields as channels. Besides that, there's also various companies that now have feature bounties, not for bugs, but to help fix problems they have. For example, TinyGrad has bounty to write code, bug fixes to help implement its framework into various GPUs. Hackathons have also become quite advanced. I know Kaggle is running some research level hackathons at this point, like ArcadeGI may as well be research level. The biggest pros with top down is you essentially know what's going on in the cutting edge of things. So if you are re-implementing papers, you essentially know what's going on in the top down, the cutting edge of things. Thus you'll be able to understand an intuitive understanding of just like the math and get really just like hands-on experience versus like numbers and theories on the screen for low level. The biggest con is that it's discipline driven because you'll be confused a lot, especially if you don't have or very little math or CS background. So you'll be asking the model a lot to help you. For bottom up, the biggest pro is that it gives you a view of some techniques that may not be used anymore, and it's easier to follow, while the biggest con is that it's usually not fully up to date with existing literature. Like I know some places still use scikit-learn, which isn't really used anymore. Chapter 6. How to get more people into this point. The current state of things / public perception. Most undergrads or boot camps tend to stop right at undergrad rather than upskill some more, usually because of course issues with finding work or the boot camps just not being advanced enough. Besides papers and outside of AI, a lot of grad software requires help from CS. Most are used in research in varying fields, and I think that's also a good start with beginning in open science, especially if you're out of undergrad and looking to upskill. So helping out the grad students with their software might be a good start to open science. Most users are in the US, but there's a large amount of people in India who wants to help as well. As a whole though, users would rather apply if things are more formal, for example a fellowship, rather than more casual, for example a GitHub repo. This has led to skill issues with people who are underskilled since they haven't really done any non-formal stuff and think they can help. What can we do to grow this place? We can create more spots for people to upskill to and then get them here. That is upskill from diploma level to like masters or junior researchers. We could get some of these groups or experts to talk to each other more often. A lot of communities or experts are very closed off and aren't aware of the other groups or experts doing stuff. Essentially just networking experts with each other. Or we can have more IRL hackerspaces and fellowships and so forth. But I don't think that would be the best use of money because it's more localized. I guess maybe for non-computer science stuff it might be needed. In other words, we're getting a lot of newcomers to join and upskill, or we're getting a bunch of experts to link with each other. Despite there being more newcomers, I think because of the high drop-off rates, I think both would probably get around the same amount of people either way. Issues getting people here. One of the bigger issues is that the general public wouldn't think of research as a viable option or traditional path. A change of this style of thinking to thinking of research as another path to choose would be incredibly useful in boosting the amount of people here. Science communication, that is, also plays a factor into this style of thinking. The Summer of Math Expedition by Tree Blue Ron Brown has helped shine a light on who's doing what. Something else of note is that there is a difference between doing a course online, doing research for someone, and doing research for yourself. It tends to be best to do all three in sequential order. That is, you do a course first, then you do research for somebody, then you do a research for yourself. So you get the soft skills needed for each. For example, a project more actionable, you probably wouldn't be doing a literature review. So like, let's say someone wants you to help with their project and all you need to do is just write some code. You probably wouldn't be doing a literature review for that. But for your own project, you'll probably need to be writing code and doing a literature review. I think it would also create a lot more people reading research papers or doing advanced tutorials, which is a soft prerequisite for being able to do research, which there isn't much reading groups outside of academia. It's really kind of a web of issues of anything past undergrad equivalent being more difficult to access, leading to less people being able to do stuff even if they're fine here, leading to less people thinking it's a path doing well in life, as well as people already in master's equivalent not knowing about here, or just in academia. More mentors, better upskilling to get people up to this point, something to bridge the gap between undergrad equivalent and research would be great. Or better impact by asking professors, research companies and so forth open problems to work on could be a good way to help people reach here. BioXYZ kind of does this, although more fields should join, with skill levels stopping users from falling for a crank project or a GPT wrapper. Realistically, issues to get people to this point, especially with regards to being able to do research, would require deep cultural changes. To just connecting people who are already skilled, high ambition, to researchers and so forth seems to be easier and higher impact to do, which is what most of the AI safety orgs and some of effective altruism does. Shifting the global culture into taking research more seriously would require the help of memes or something. You know, like all those cultural mimetic marketing stuff. Like, do you see how entrepreneurial culture is? Where like people kind of think of entrepreneurial culture as like hustle culture rather than like starting a industry research lab or something like that with all of the success stories and stuff. Like, I think if we get research to have a culture like that, we could see more people here, although it would harm the quality. Or the whole thing about some people not being able to think about stuff, aka learn helplessness from thinking narrowly in school or societal norms or education being a checklist. I.e., you know how in schools like there's a syllabus you have to learn rather than like learning for the sake of learning, or like you're learning to understand what it means essentially. Laziness might also be an issue, but I don't see it as a major issue. I think it's more so people just not knowing how to search for stuff out there, mostly cause the ability to like search and like learn and stuff is more so learned in like PhDs or researchy extracurriculars or pastimes, which is why there's sometimes situations where undergrads are more knowledgeable than the masters because they've done a lot more extracurriculars, especially more practical ones. Or the problem where people attempt research, realizes it's hard, then gives up, except research is failing repeatedly. If you've made something, example a write-up video, you know how much extra time it takes to produce the content that gets tossed out. Relates to people in fellowships and so forth just leaving after the first week. I think a lot of people could retrain themselves, akin to doing a PhD, but it would probably destroy most of their free time or ability to consume content and so forth. This conversation regarding using marketing tactics can go on for a while. Just think of any aspect of human behavior or societal structure and it explains why so few people are doing this kind of independent research or could get to that point. There is potential here to shift the ideologies through memetics and advertisement tactics and so forth though. Yeah, I'm actually trying to do this myself. I'm literally trying to sign up people into loving science. As a quick fire of issues, learned helplessness from failing grades/school, no payment compared to working a dead-end job, no time to do research when home, don't know how to go from massive online courses to reading papers, the IRL group dynamics don't see research as a career path or just general distrust in science, the path of least resistance leading to people not doing things out of the norm, the various discoverability issues. People just aren't real with themselves. How many of you all said you'll go to the gym or do something from January and then just stopped early on? Unknown unknowns stopping people from gauging skill levels, which relates to the crackpot problem, and a lot of various stuff are coupled to these with varying impact. The hustle culture slash gig economy as the most commonplace extracurricular, people going into job stripping, side businesses rather than upskill, lots of misinformation, misunderstanding of the crisis in science. Feel free to ask me about the double crisis in science. I could probably explain it in the comments. The general passive consumptionness relates to the passivity of learning. Academic culture being split into multiple subgroups, more noticeable for diplomas, which gets coupled into PhD life, which relates to views on science for the public. Pop culture views on what a scientist slash researcher is. The lack of researcher culture, and views of learning as a checklist rather than something active. So why don't people already do these things? That is, go to these open science labs and upskill. If you try googling an AI course, you'll be shown a bunch of incredibly expensive courses that might not teach you the skills needed. This is usually because research skills are different from applied skills in AI. In other words, an AI course can probably tell you how to implement a transformer architecture, but not actually explain what it is, what latent space is. In other words, a lot of the courses are more code based or applied. If you're new to AI, it's kind of hard to know what to pick as it's an unknown unknown. Experts in the field looking to find these spots will also find it difficult because it's mostly known through word of mouth, which is good to stop the crackpot problem. It's a trade-off, but I think there might be ways to help both groups. For example, some kind of verification through some way to show your skill level. Maybe like active, but that might be a catch-22. Word of mouth from the other learning spots, write-ups you did on Less Wrong. I'm not fully sure. The passivity of learning. Most groups tend to do what's given to them. For example, a bootcamp or course that was advertised to them rather than looking around. This is probably because upskilling past the point is hard, and no one really trusts or uses Claude yet for these things despite its potential, and Claude itself might not fully be useful if you don't know what you're looking for either. It's hard to break out of the cycle of thinking. It's like that thing where everyone in self-help thinks the right thing to do is read how to win friends and influence people, even though it's not really that useful. Probably because they don't have someone with a PhD or something, successful businessman for example, to guide them with the next steps. There is an issue here of people thinking that learning mostly takes place in school/uni, not really thinking you will need to learn more during your job. Much more true for research, since you need to do literature review, sometimes requiring extra skills you need to learn to pass the literature. I think the biggest filter to anyone who manages to reach this point, that is getting the server or the research one, wanting to write a paper or self-study, is motivation. Like 80% of all people in self-study just leave because of this motivation issue. Well, I'm not fully sure on that. I know like around 80% leave in the MOOCs, but I'm not sure if it's because of motivation. Even when people reach to doing papers, they sometimes just do whatever people tell them to do. Essentially, there's the motivation issue, low executive function, and then the inability to find good resources or know what to do. In other words, low agency. Chapter 7. Why go into open science? Resume boost, learning, career forward. I do think writing papers would be a great way to boost your resume and learn if you aren't from an academic background and looking to do research work. Various open science people went on to work in the major labs, usually with them having little to no formal education background. A great example here would be Leo Gao, who himself co-founded Eluter AI and is now working at OpenAI. No formal education as far as I can tell. There are a lot of other names I can list here, but the groups are still decently new for any real quantitative analysis, or even figure out people who tried and failed this pipeline, excluding people who started and didn't actually complete their project. For example, from writing papers, some tend to go on to get a job in industry as a junior researcher and so forth with no formal education, or showing skills with helping out the GitHub projects the labs use and create and hiring someone from there. It's just a great stepping stone to go into working for the closed source labs or industry/government contracts, or start a technical startup, especially for non-traditional academics, as well as all the bounties you can do that gives internships and jobs at companies. It's kind of like how doing your own Substack now sometimes gives you a journalism hire. Networking, fellowships, get advanced help. Great spots to get help with any advanced problems you might have, and find people to work on your project with you. Although most of this is specifically for AI and any AI related fields. AI safety, research, and policy fellowships and research sprints and so forth are great ways to do research. They are similar to hackathons but usually go on for a longer time, usually at various times of the year, as well as all the beginner programs tend to have some kind of sprint. These are usually linked to the labs as well sometimes. For example, the Maths fellowships is sometimes linked to the research server. Besides the labs, there are usually IRL fellowships or research tracks, sometimes with a stipend, which is usually a decent amount of money if you aren't in the US. These tend to be more personalized if you aren't motivated, but can lead to more issues, for example bad reputation if you lead the track early on, or ghost and so forth. It does help with networking and investor finding too, as the labs are usually funded by some of the philanthropic organizations, and some of the members or the tracks go on to start companies and get seed funding. This depends on a track. More entrepreneurial ones might have this occur more commonly. Science communication. Besides that, I do think this could help with science communication if you're interested in a field, as you get to meet experts and ask them questions and so forth in the subfield they're working on. Also, generally, what are you planning to do with your free time? I think especially if you haven't done research or been in research circles, there's a lot of cultural and social unknowns that you may be wrong about that the public thinks is true. Why did mostly computer science, more specifically AI, rise to this occasion? You only need a computer and data to do research. You're not going to become a medical professional doing open science, as there isn't really a path to start doing medicine in the open. No one's going to let you operate on them, for example, and new papers in medicine tends to be created by events doctors see in real life, or like N of 1 cases, at least sometimes depending on the subfield. Humanities also feels like it has a set of pseudo-researchers as well, at least for political science and philosophy and so forth. This probably relates to the paper crisis there and their paper quality, as well as larger lobbyists and so forth cherry picking papers to use and being harder to replicate studies compared to computer science, where all you need to do is just copy some code from the GitHub/paper and test it yourself. Biology and chemistry and so forth has a lot more advanced online courses online, but mostly for the informatics subfield, but it's hard to go from there, especially if you need to synthesize materials or aren't in a country where there's open labs or hackerspaces that usually has all the chemicals and tools required. Like, I know there's the DIY bio program, which are useful for bio. Like, you can make bioplastics at home, but it does require some course for the experiments, which can make things a bit difficult. As well as, I think, if you're doing like extremely low cost science, you will probably require a deep knowledge of the field that you probably would not get with like a year of experience. It's really a multitude of factors, such as but not limited to open science and computer science movement away from academia already being a thing pre-Discord, like GitHub was here already. There just being more people in computer science, more unemployed or underemployed people in computer science. Most other fields work in their uni, labs, or industry. The general computer science culture as a whole It's easier to test papers in computer science, for example, as well as just the lower barrier of entry in computer science. Most of the advanced courses in computer science are online and easily replicatable. Most people just aren't aware of other subfields because it isn't marketed like computer science. And computer science teaches you a lot of research soft skills indirectly, so it's not too difficult to start doing research. The lower skill floor, so people don't spend as long learning to do research, is especially true in AI, because there's a lot of low-hanging fruits in AI still. AI especially is all online for all the same reasons. Everything can be done virtually, no need for hackerspaces for robotics, and you can test the code online. In other words, it's the you can just do things mindset, and as such, people grew and became more aware of these places. A lot of those factors are probably also why there are so much high school type research groups. There's a lower gap in those places, it's easy entry, and you have a lot of free time, so you can do your own research and so forth. Biohacking is probably the closest to AI open science labs culture-wise, but it's all in real life and they're all currently in a research winter. There are a bunch of grad servers for the other fields, for example math, but it's closer to Stack Exchange where people are asking questions and getting answers for their own work rather than like helping out people with a larger piece of work. Like there isn't too much collaboration going on. Anyone doing co-working in other fields is mostly in private hubs or just their DMs where they already know the person in real life or beforehand, so they aren't really looking for people online to collaborate with. One group that seems to be having success is the independent science group I talked about earlier. They are new and they are doing some physics stuff, which is pretty interesting. Chapter 9. I have my own research, but it's very unique, different, but almost certainly not crackpot. What do I do? I'm guessing you talk to the experts or still can't find the experts. If so, I've sent 3 links here. One is bootstrapping open research, and X is the Cosmic Network, and the third is Exa AI. The basic TLDR is that because each subfield is so small, like there's less than 100 people doing research in your subfield, you might need to do a semantic search to find your peers. They might not be in a Discord or other spot somewhere. I think it's especially true if you're not from an academic background and you're using words that aren't the keywords for the subfield you're looking at essentially. Chapter 10. So what can I do? Non-computer science adjacent. If you're already an expert, try looking at the pipeline required to make it to where you are today. If there are any places that are free, open source and so forth, please make note of that and try building a community, advertising to those free open source spots to those new in the field, while also getting people together to do research in your field. If you aren't an expert, try upskilling. You're probably still a bit to go before being able to do research. Maybe ask around what paths to take in the most social graduate spots. Even if you don't want to do research, you should still upskill. Having an advanced knowledge of things can help you decide if you want to go to the entrepreneurial path as well. Computer science adjacent. If you're already done with an undergrad type course or at the point you can replicate papers, try joining the labs. They can usually help you in the right direction if you have a subfield in mind, or to the study resources or compute resources if needed. If your undergrad had a lot of AI in it, or you did an advanced AI course as well, for example a master's or PhD, you can come join us. Feel free to help out or put your own research that requires help, or look and join whenever we read research papers. Otherwise, try upskilling some more. You can still join the labs as it is a soft requirement to do research, while there is no requirement for the reading groups, but you might not get too much out of it. They can point you in the right direction, but there might be better choices. If you're specifically in high school, you can also join the high school labs. For example, Rishab Academy has an aggregate of most of them. Maybe there are talent agencies for science, but I haven't looked into them too much. Also, if you are listening to this, I did add a link to all of the servers near the bottom of this write-up. The spreadsheet has all of the computer science type Discord lab AI labs. For both groups, there's also a bunch of links on project ideas, abandoned research gaps, various open source problems you should help with, and so forth. There's a link right here at chapter 10. If you're listening to this, you should probably look at these links. The spreadsheet is once again near the bottom of the post though. Funding organizations. You should probably fund these communities as they tend to create a lot of impact, as it's a really good third space, or really just a space where people can do extracurricular stuff, I guess. The spreadsheet for all of these servers are at the bottom of the post, but the main groups here are, from my point of view, for AI research would be eLooter, Cohere Labs, the Alignment Jams or Path Research, AI Plans, and Neuromorphic. For the non-AI, there's Manifold Research Group and Independent Science. I am willing to hop on a call or respond to any messages about the sheet, who to fund and so forth, but in general, I can't say who to fund. I mean, the above are safe picks, but I'm not sure if the lower impact spots would be better if they get funding. It's kind of that problem where all the best spots get funding, so they just keep being good. There's also the suite of GitHub projects that would want funding too. It's in the third sheet in the sheet. You can also try to run some grants for these stuff, as from what I can tell, they tend to fall outside of most of the typical grants. Also, feel free to fund me. This was actually being done by me part-time, and I would love to move full-time for this. I did set up a ManiFund link. There is some more information further down, as well as a link right here. You want to build a community. The biggest things working against you here is time. You really need to put in a lot of time to micromanage everything early on when things are moving quickly, and make sure people don't leave early on while the community is building. Afterwards it will snowball and you can be more hands-off, kind of like an entrepreneurial project really. Some suggestions are demo days, share your work, weekly events, write-ups of discussion had, spreadsheets of who's doing what, who wants to help, so things aren't an ideas soup. Notion, Coda, so ideas aren't on Discord, since Discord moves quickly and it will be forgotten if you leave it on Discord. Guides on how to use Git to help ease friction. You can also put the guides on the Notion Coda. Draconian type rulings so people don't procrastinate. Just like bug people to do work, I guess. Incentives, stipends, certificates. Really, if it's a bit more formal, like saying you're doing an 8-week sprint, will get more people here, I guess. Weekly check-ins, task boards, open research calls so contributors can see what to do, apprenticeships and those sorts of stuff. Design around the people staying active, as a lot of places have high dropout rates. So just design around 10% or so who's still active in the community. Videos, collabs, conferences and those stuff to help with recruitment. You can usually do these stuff after a project is completed. Kind of like a project showcase, but you're using the project showcase to just get more people here. AI to help with boilerplate, project pitches, any real small stuff really. Experts to help with quality control. Work with universities, companies, publish everything open, industry demo days to companies, like chat with companies about what you're up to, chat with professors about what you're up to. Various rules to help with any IP drama from working with companies and universities. Partner with hackerspaces and so forth to use their equipment if required, but post the results online. Kind of like a video research paper. It can help a lot with marketing and understanding of what's being done. Also, you should really think about your skill base, the skills of all of the people you have. Like, are they enough to do research you want? If not, how long do you think it would take to upskill them? Make the space for the people who's active, once again. These should all help move an existing community from just chatting about science to doing science. The biggest problem I've seen with these types of groups, cohorts, even some fellowships and events, is the high drop-off after week 1 or so. Having a burn-in period could help. For example, coding exercises, do some basic merge requests for some GitHub projects. Resumes could be useful, but skills are pretty vague on resumes. Like, everyone says they're good at Python, but that doesn't really mean much. This could just be a problem everywhere and safely ignored though. Although I have no clue what these people are doing after they just keep leaving. Chapter 11, Future Trends. With the funding cuts, I guess we might see more people taking this career path, especially if they would otherwise not be in training or education. Maybe we might see more people in humanities and math. I don't see math being too collaborative because of the nature of the work though. Humanities may see an uptick, especially if more people become interested in internet type data science research, and well, humanities is in a weird spot right now. There's a lot of groups in political science and stuff. Perhaps more free courses for those fields might occur too. Math could use more, humanities could use more, all other fields could really use more, especially for the sub fields. But I don't think it will be too much because all fields really tend to be more using pen and paper rather than like code. Perhaps even more computer science adjacent subfields might have groups now. The DAOs have created a group for a lot of variant science and computer science and interdisciplinary stuff, the bioinformatic, chemoinformatic stuff, but there are probably still some gaps. And I think the larger online ecosystem will probably develop some more with some more fellowships, hackathons, more groups. I mean, essentially there's only like 5 to 20 open science labs. There aren't too much spots compared to all the regular unis. There are all the CS spots that at least feel master-worthy, like all the Python learning spot, the Rust spots, but they don't do well, they kind of do research, but most of it is more education focused. Like these people, like they develop the Rust code base and stuff, for example. If I compiled hackerspaces and research and internships and so forth, it might look bigger though, especially for humanities, but I don't think it would be like bigger than 5% of what universities have in total. Partially because I think in a lot of the internships and stuff, some of them went on to university or they got jobs, or like the people who are in the hackerspace and internships are from universities. Might be decently higher if I just include diploma holders maybe. In humanities especially, it feels like SciComm has a higher impact than formal researchers. I'm not really sure where to put diploma holders in all of this, to be honest. Perhaps the new juniors in research get all the grunt work like they're the new masters and PhDs. Extra, difference between research and entrepreneurship. Entrepreneurial and research tends to be similar depending on what you are doing. For example, if you make a new material, you could attempt to upscale it and sell it to businesses or consumers who would want it, or write a paper about it. Not all entrepreneurial projects can be papers though. For example, if the material is clearly another material with something that would have been obvious, for example, a phone that does nothing in 2025 would not be paper-worthy, but an Android phone in 2005 would be paper-worthy. Not all papers can be entrepreneurial projects either. For example, a code or technique that increases an AI score or trustworthiness score by a few percentage points can't be an entrepreneurial project. But a series of papers compiled can definitely be used to start a consultancy or otherwise some type of industry research lab type business. From what I've seen, most groups go from academia to entrepreneurship rather than the other way around. I think that's because, let's say if you have 10 years in entrepreneurship in a research lab, that is not something like, let's say, dropshipping, you're probably a senior at that point. Like, you probably have the medical knowledge if you went into like a bio-based startup. So like, there's no point in doing grad school at that point because you're already an expert and you're already doing research. There is some other issues like entrepreneurship, meaning like dropshipping to the general public, which is not what I'm referring to. There is other stuff like culture here that I touched on. Once again, I am looking for funding to turn this into a book. Chapter 12, Conclusion. The emergence of open science labs represents a fundamental shift in how research is conducted in the 21st century. What began as informal Discord communities has evolved into legitimate research collectives producing peer-reviewed papers, launching careers, and challenging the traditional academic monopoly on knowledge creation. This movement addresses several critical issues in modern research: the accessibility gap for those outside traditional academia, the siloing of expertise across disciplines, and the inefficiency of conventional research pathways. By lowering barriers to entry while maintaining quality through community peer review, these labs have created a new model for collaborative science. The success stories, from EleuterAI's ICLR papers to various DAOs funding applied research, demonstrate that this isn't merely a hobbyist movement but a viable alternate research ecosystem. For computer science and adjacent field, this has already become proven pathway. The question now is whether other disciplines can adapt this model to their own constraints and cultures. The open science movement isn't just about democratizing who can do research, it's about reimagining what research communities can be. In an era of rapid technological change and complex global challenges, we need all available talent contributing to human knowledge. These Discord servers turned research labs might be the prototype for how we organize scientific collaboration in the future. In a world where knowledge work is increasingly accessible, the question isn't whether you can contribute to research, but whether you will. What are the next walls to fall? If you are listening to this, I still have to go through why I written this, funding and contacts. I've listed my 4 contacts here, but you can also just write a comment to this post and I'll look at it as well. So why did I write this? I think I've also noticed that a lot of the culture in the poorer countries, the one I'm from notably, a lot of people think you should go to uni, be a doctor, do computer science, but a lot of the courses tend to stop at like Python, which is kind of unfortunate. I guess there's not much people doing like research stuff here, more so like startups, but not like technical startups. And I do hope to change that. I have been seeing more advanced courses in AI and data science and so forth, but not much work in moving to the research side of things, especially because of all the issues I've stated earlier. But realistically, these issues go much deeper, relating to the problems with, well, all the psychological, not really psychological, just like the societal, socio-economic kind of problems and so forth. A rebranding of science can probably fix this, but I do think it goes much deeper. I might be doing something with this as well. Besides that, I should have my first paper out on Arxiv by the end of this year. So what am I going to be doing now? Well, I kind of need funding actually, as this was done part-time by me, but the first major thing is to finish the AI ecosystem map. It's currently a spreadsheet of over 400 Discord servers, but I'm hoping to add all of the Facebook, Slack, WhatsApp, Telegram, QQ I think it was, all those groups, some probably non-AI research groups as well, kind of like independent researchers, independent scientists, but I kind of need funding for that so I can work on it full time. I also need a bit of funding to move the site from a GitHub page to a working kind of backend page. We did the project, the website for the SOAR program. It wasn't built by me, but I really like it how it came out. There's still some work that I'll have to do on it though. But most of the spreadsheet was built by me. I pretty much made and got pretty much all of the links myself, except for like a handful of sites in there. If you're reading this, you really should look at the spreadsheet, by the way, or the website. It's really useful if you want to go into AI, and there's some non-AI adjacent stuff in there as well, like the independent physics group, some bio groups, some chem groups, and so forth. Next up, I still have a lot of things I want to talk about in regards to Open Science Research Lab. I'd like to just turn this right up into a book. I mean, it's already 40 minutes long. I just have to like double the length, and there really is a lot of extra stuff to write about. Thirdly, I'd like to get more people here into Open Science Research Labs. I'm thinking of doing it both ways, where I connect people with each other, where I just connect like the experts with other experts who are in different servers and spaces to talk to each other. But I'm also thinking about a larger plan of like getting the general public interested in science using like a change in culture. Like, I have been getting DMs for the past 3 or so months informally where people just DM me asking for help because they know I'm knowledgeable in these sort of stuff, and I just send them links. I know at least one person was able to co-help write a research paper, but not too much so far, although it's like 8 people in total who DM'd me. If required, monetize the spreadsheet maybe somehow, but I hope that I don't need to do that. A more interesting idea was having each person be their own stock, kind of like if you've ever used manifold markets and saw those person stocks, where if the person is doing well in life, their stock goes up. Something like that for all the newcomers might be interesting, because it would help both with the funding issue where they don't have any funds to like be self-taught or just like learn in their free time. But I think it comes with a lot of massive risks, but it's something I would be interested in looking into. As for stuff I'm not really interested in doing, I'm not really planning to make like a spreadsheet of everyone's skill levels and what they're looking for. LinkedIn kind of does that, and I mean, if I do that, it kind of feels like a lot of people will be just DDoSing the grad people, and like a lot of people just don't know their skill levels and so forth. So yeah, I'm not too interested in doing that. I think the same issue is actually for like creating bounties for projects, because I'm not skilled enough to know what projects there are out there to do, like what open research problems or research gaps there are to do. I am willing to help direct funding, but I think subject matter experts should help with the research gaps on what they would want open science labs to be doing. The Discord spreadsheet was made from around October of last year to about May of this year. Afterwards, like, not too much servers were added after that time, mostly because I got busy. If you're deeper into alignment or policy, there's also the AI safety site, which has something similar, but I don't think they're too technical. There's also the website as well, rather than the Google Sheets that I made for the SOAR program. That's Eluter's fellowship that was being ran, I think, from last month to this month. From what I can tell though, the sheet has been incredibly high impact. I can't really measure how high impact it's been, but I can tell it's been used by a lot of people, and I really do wish to get funding to just finish the sheet essentially. I think the number of sites and groups in that server sheet could go well up to like 1,000. Although I think for quality wise, servers that get a score of more than 7, just like groups in general, I think there's probably like 200 or so. This includes non-Discord stuff as well. But yes, I think it's very high impact. Once again, I am in a weird spot because most groups won't be funding something like what I'm doing here, because it's not fully alignment oriented, nor is it really OpenSci oriented in the traditional sense. If you have any links or contacts to someone who would want to fund this, do let me know or put a good word in for me. I have posted a ManiFund link as well if you want to help with that. Other than that, there's also the Foundation Center maps if you want funding. Maybe it might be useful to you. As well as there's an aggregate of some funding in the AI safety links I put here. I actually haven't applied to any of the EA grant funding yet. If you know any more stuff about those funding or really any funding in general, please do reach out. I wanted to wait until this write-up and sheet is out in this state before applying. So I will be applying soon, so please do reach out, check my contacts in this post to message me. Now some suggested reading. How to do research. A lot of the links I sent here is kind of a guide on how to do research. Just like, how to do a lit review, how to think about research, upskilling, just like unknown unknowns and stuff like that. There aren't too much papers on open science labs. There might be some conferences on cultivating open source AI research, not too sure on that. I did find one link on stillness and research kind of useful, but it's not too useful for me, but it is fine. I think when you're starting out, there's just a lot of things you can't try until you try something that works for you. I guess for me it was just being able to just do things rather than like having some kind of hyper optimal setup and just use the bare minimum for what's required, which has come back to bite me in some ways, especially when making that sheet. There's a lot of data cleaning that had to be done for that sheet, for example. I don't have too much faith in like self-control-esque stuff, but like maybe it might work for you. Wasn't sure where to put this, but if you feel like reading is boring, try reading through more of your sections in a way where you're reading the words quicker than your voice is able to reason them. I think it works best for articles you have an idea of what's it talking about. Really helps me with stuff I already have an idea of. Kind of like how I just did that. I've seen scientists, at least online, get managers a few times just to help them with like procrastination and motivation issues. I think it's kind of interesting to see these issues plaguing nigh everyone. Scientific Freedom by Donald Braban seems like an interesting book that might be related to this topic. I will be reading it soon. Memes and stuff. I've made like 30 memes of what I've talked about in this article. You can see it in the links below. I've also posted a few here. I've also made a Claude artifact, but I don't really like it. The memes themselves are pretty informative and kind of funny, although some might be anti-PhD vibes, which is not what I was hoping for, as well as a few things feel like it's missing in relation to the memes, but I guess you can share it with whoever. Yeah, but I just don't see it getting too much traction because I haven't like related it to cultures or anything like that. Special thanks to Neil Nanda for data on his team's skill level, Gentix for help with various stuff and putting together the SOAR program which directly shaped some of my views, Madeline of Cohere Research for their views on community building, Quentin Anthony of Eluter for views on research managers, Afik of Casual Physics Enjoyer, independent scientist for views on open physics, Dust for views on what's going on in the biology hackerspace, and various others who DM'd me over the past 3 months about this write-up. I am once again looking for funding to do this full time, and thanks for listening to this post. Feel free to leave a comment or message me and so forth. My DMs are very open.